Hi and welcome everyone to one more lecture of probability and statistics. Today we will learn about regression coefficients, their properties and how we can find out angle between two regression lines. As we have learned that for regression line y on x, we denote this as y is equal to a plus bx, and as we know, if we will summation on both sides, summation y equals to na plus b summation x, which was our equation 1. And similarly, if we will multiply both sides with summation x, this will be summation xy equals to a summation x plus b summation x square. This was our equation 2. But we can write this regression line in one another form, which is y minus y bar. This is mean value of y equals to r sigma y by sigma x minus xy. And similarly, for x on y, we can write equation x is equal to a plus by in another form similar to this, which is x minus x bar equals to r sigma x by sigma y minus y bar. Now we can also write this as b yx into x minus x bar, and x minus x bar equals to bx y minus y bar. Now byx is regression coefficient for line y on x. Similarly, bxy is regression coefficient for line x on y. We can note this one thing: if we are writing x on y, x is before y, and similarly in this coefficient, and yx stands for regression line y on x. And in these equations, if y is on the left side, y is also in the numerator, and similarly if x is on the left side, x is in the numerator. Now byx and bxy are our regression coefficient. As we know, byx equals to r sigma y by sigma x, and if we will put value of r, which is r is correlation coefficient, so if we will put value of r, that is covariance xy by sigma x sigma y, and we will multiply this by sigma y by sigma x, so byx equals to covariance of xy by sigma x both are in denominator, sigma x square, and sigma y, one in denominator, one in numerator, they will cancel out. So byx equals to sigma xy, covariance of xy by sigma x square. And similarly, bxy will be equal to sigma xy by sigma y square. You can note this one thing: if y is in the second place, y will be in denominator. Properties of our regression coefficient. regression coefficient. First property is that our correlation coefficient is geometric mean of regression coefficient. Regression coefficient are bxy, that equals to r sigma x by sigma y, byx r sigma y by sigma x. If r is geometric mean of bxy and byx, so r should be equal to under root bxy dot byx. That means r square equals to bxy dot byx. We have to prove this to say that r is geometric mean of bxy and byx. Now, if we multiply bxy and byx, bxy byx equals to r sigma x by sigma y dot r sigma y by sigma x. Sigma y cancel, sigma x cancel, equals to r square. So our r is geometric mean of regression coefficients and sine of r is sine of regression coefficients. That means regression coefficients and correlation coefficients have same sign. Our second property is if one of the regression coefficients greater than 1, then other should be less than 1. Let's say if bxy greater than 1, then it is necessary for byx to be less than 1. As we know, bxy and byx equals to r square, and r square lies between 0 to 1. Because r lies between -1 to 1. So bxy and byx also lies between 0 to 1, and therefore this product should always be less than or equal to 1. That's why if 1 is greater than 1, then other must be less than 1. Third property is that as we know, AM always greater than or equal to GM. So as we know, GM ohm of bxy and byx equals to r. Therefore, AM of this should be greater than or equal to r. That's why 1 by 2 modulus of bxy plus byx greater than or equal to r. The fourth property is that byx and bxy independent of change in origin but dependent on change in scale. That means b of ay comma bx not equal to byx but b of y plus a comma x plus b equals to byx. That means if we change the scale, our regression coefficient value will be changed, and if we change the origin, our regression coefficient value will be same. Our next point is angle between regression lines. Angle between regression lines. Our line for y on x is y minus y bar equals to r sigma y by sigma x, x minus x1. And our line for x on y is x minus x bar equals to r sigma x by sigma y upon y minus y1. Now we will change the second line in terms of y so that we can find out slope of the lines, because slope of the lines is the main ingredient to calculate angle between lines. And we know tan theta equals to m1 minus m2 by 1 plus m1 m2, where m1 and m2 are slope of both the lines. Now we have to calculate m1 m2. So our first line is y equals to r sigma y sigma x into x minus r sigma y sigma x x bar plus y bar. We can write our second line as y minus y bar equals to x minus x bar times sigma y by r sigma x. So y will be equal to sigma y by r sigma x dot x minus sigma y r sigma x times x bar plus y bar. Now slope is coefficient of variable x, so m1 will be, let's say this is our equation 1 and this is our equation 2, so m1 will be r sigma y by sigma x and m2 is sigma y r sigma x. Now if we will just put these two values in our formula, tan theta equals to r sigma y sigma x minus sigma y r sigma x 1 plus m1 r sigma y sigma x dot sigma y r sigma x. If we will multiply these two, r and r will be cancelled out and our denominator will be sigma x square upon sigma x square plus sigma y square, and our numerator will be our denominator is LCM of these two, so this will be r sigma x by me. Now we will multiply this numerator by r square sigma y minus sigma y. If we will solve this, we can take sigma y by common from this numerator, so this will be r square minus 1 by sigma x times r by sigma x square plus sigma y square by sigma x square. Now we will solve this part further. Then sigma y, sigma x square, they both are in numerator, so we will just cancel out sigma x. So this will be r square minus 1 by mod r by r into sigma x sigma y by sigma x square plus sigma y square. का modulus. Now, as we know that r lies between -1 to 1, so r square will be lying between 0 to 1, and r square is always less than or equal to 1. So if we have to open this modulus, we can write this as 1 minus r square by mod r times sigma x sigma y sigma x square plus sigma y square. This is value of tan theta, and if we have to find out theta, so this will be equal to tan inverse 1 minus r square by mod r sigma x sigma y by sigma x square plus sigma y square. This is our formula for angle between regression lines. Now, from our formula, theta is equal to tan inverse 1 minus r square by r sigma x sigma I sigma x square plus sigma y square. We can get two observations. First is, if r equals to 0, then our theta will be equal to pi by 2. That means if x and y are uncorrelated, then these regression lines will be perpendicular to each other. And our second observation is, if r equals to plus minus 1, then tan theta will be equal to infinity and theta will be equal to 0 degree or pi. If theta is equal to 0, then these regression lines will coincide, and if theta is equal to pi, then these lines, we can get that these lines are parallel or these are coinciding. Then, as we know that these two lines are passing from the point x bar y bar, then these lines cannot be parallel because parallel lines do not have any common point. Therefore, these lines are coinciding. If r equals to plus minus 1, that is, our variables are perfectly correlated. That means if x equals to y or x equals to minus y. Now we will solve a question to grip out our concepts. Our question is, we have to find regression coefficient and line of regression for data. This is values for x and this is values for y. Now we have to find b x y. This equals to sigma xy by sigma y square. So we have to find sigma xy and sigma y square. Sigma xy equals to E of xy minus Ex Ey, and sigma y square equals to E of x square minus Ex whole square. Now we will find the values for x square, y square and xy. Now x square will be 1, 4, 9, 16, 25, 36, 49. Y square 81, 64, 100, 144, 121, 169, 196. XY 9, 16, 30, 48, 55, 13 6 जो 3 6 18, 78 and 98. E of x equals to x bar or equals to summation x by n. Summation x 1, 1, 2, 3, 3, 3, 4, 3, 3, 6, 6 and 4, 10, 15, 21 and 28. 28 by 7 that equals to 4. EY 9, 8, 70, 17 and 10, 27, 27 and 12, 39, 39 and 11, 50, 63 and 77 by 7, 11. EX square. EX square will be 1, 4, 5, 5 and 9, 14, 14 and 16, 30, 30 and 25, 65 and 65 and 36, 101 and 101 and 49, 150 by 7. E of y square. 1 and 4, 5, 5, 9, 10, 19, 25. 5, carry 2, 10, 16, 16, 20, 22, 28, 28 and 9, 37. 3 carry. 4, 5, 6, 7, 8. 875 by 7. E of xy. 9, 9 and 6, 15, 15, 15 and 8, that will be 23, 28, 28 and 8, 36, 36 and 8, 44, 4, 5, 5 and 3, 8, 8 and 4, 12, 12 and 5, 17, 17 and 7, 24, 24 and 9, 33. Now we have to just put these values. So sigma xy will be 334 by 7 minus E of x 28 by 7 into E of y. We will just put this value 11. So this will be 7, 334 and 28, 28. This will be 308 minus 308. So this will be 7 and 8, 26. So sigma xy is 26 by 7 and sigma y is E of x square 1 by 150 by 7 minus E of x, that is E of y, sigma y, then this will be E of y square minus EY whole square. So this will be 875 by 7 minus 11 into 11. So this will be 875 by 7 minus 121 and 121 into 7 will be 748. 847. 7, 8 and 2. So bxy equals to sigma xy, that is 26 by 7 divided by sigma y square, this is 28 by 7. So this will be 26 by 28 and you can further solve this value. Now we will solve a question to get grip on our concepts. So our question is we have to calculate regression coefficients and line of regression for these data, and I have already calculated values for x square, y square, xy, and values for ex, ey, exy, ex square and ey square. As first we will calculate byx, and this equals to covariance of x y by sigma x square, as we have already learned in this lecture only that whatever variable is in the second place, this variance will become in the denominator for that variable. Now covariance of xy equals to exy minus ex ey, and sigma x square equals to e of x square minus ex whole square. Now we will just put these values in these equations to get these values. So sigma xy, covariance of xy will be exy 334 by 7 minus ex 28 by 7 into 77 by 7. We can divide on both of these values. So we will get 334 and 28 times 11, this will be 308. So this value will be 34 minus 8, 26 by 7. And sigma x square will be e of x square 140 by 7 minus ex whole square 28 by 7 into 28 by 7. If we will divide both of these numbers from 7, this will be 4 and this will be 1. Our LC will be 7. 148 minus 28 into 4. 8 4s are 32. 3 carry. 4 2s are 8 and 3 11. So this will be 28 by 7, and b by x will be equal to 26 by 7 divided by 28 by 7 equals to 26 by 28, and this will be equal to 13 by 40. You can calculate the exact value on your own. Now we will calculate value for bxy. So this will be sigma xy by sigma y square, and sigma xy will be again e of xy minus ex ey. We have already calculated this value, and this equals to 26 by 7 sigma y square. This will be e of y square minus ey whole square. This will be e of y square 875 by 7 minus 77 by 7 into 77 by 7. 11 1. Now LCM will be 7. 875 and 77 times 11 will be 77. 7 14 and 8. 847, and this will be 28 by 7. Now our bxy will be 26 by 7 by 28 by 7, 13 by 40. Same as our byx that we already calculated. Now we have to find our regression lines, and we have already found that bxy equals to byx equals to 26 by 28 or 13 by 14 for this particular question. Now we have lines of regressions equation y minus y bar equals to byx x minus x bar. So for line y on x, we will just put the values. As we know, y bar equals to e of y and x bar equals to e of x. So y minus y bar 11, 77 by 7 equals to 11 and 28 by 7 equals to 4 equals to b by x 13 by 14 times x minus x bar, that is 4. And for line x on y, equation will be x minus x bar equals to bxy, y minus y bar. If we will put the values, x minus 4 equals to bxy 13 by 14, y minus 11. So these are our equations for regression line, and we can also solve it further. That will be, for this 14y minus 14, 154. 154 equals to 13x minus 13 4s are 52. That means 11y minus 13x equals to, this will be 2, this will be 102. And similarly, we can also find out exact equation for line y x on y. That's all. We will continue in our next lecture. Thank you.